Yes, that may be it. So I did want to say that this week, this month, we have Kai. Many of you will know Kai as one of the leaders of the Python WA Meetup group. Kai often does very interesting presentations over there. This one has stressed him out because he is like the rest of you all. You know, he's deep in the Python, but he is trying to learn Rust, and he always wants to present a perfect presentation. I said we have no expectations of perfect. We would just like something interesting to think about. And so I'm very happy to have Kai doing that. I have put a learning path on there if you are interested in studying that particular thing. It's quite an easy learning path, so it's not like a hard thing. So yes, take a picture and look that up afterwards. But you can also, on Microsoft Learn, just search on Rust, and there's a very nice, easy learning path for introduction to Rust as well, if you'd like to try that. Of course, we are not a Microsoft aligned user group, and it is perfectly okay to be aligned to other cloud technologies and to bring your friends from those other ecosystems. It's not hurting me to say this at all. We're absolutely agnostic here, but I will try and influence you by giving you learning paths that lead you back to Microsoft. But don't feel obliged. Cool. Kai?
Yep. So is that something like that? It's obviously John.
Okay, cool. So my name's Kai. I've been learning Rust for about 3 months of weekends. So I'm not an expert, but I'd like to get better and keep learning, hopefully to use something. So this talk is about embracing lifetimes, which is basically a mechanism that Rust uses for memory management. So I'm going to start with a story about how memory management should be done. And that starts on the 21st of March, 1986. I was with page down. Yes. So on this day, a patient presented for his 9th treatment session for a tumor in his back. The treatment was said to be 22 mega electron volts electricity with a dose of 180 rads. With this first dose, he felt an electric shock and heard a crackle from the machine. I've never been to a cancer treatment, but I don't think that's what's going to happen. So we need to be a little bit careful. With the second dose, the patient felt a shock of electricity through his arm as if his hand had been torn. Also a bad sign. So what happened to the patient? The patient received a dose of between 16,000 and 25,000 rads instead of the 180 he was prescribed. The patient experienced paralysis of his arm, nausea, vomiting, and being hospitalized for radiation induced myelitis of the spinal cord. His legs, mid-diaphragm, and vocal cords were paralyzed. He also had recurrent herpes simplex skin infections, and he died 5 months of the early dose. So what actually happened? This bug happened because there was a race condition. The operator initially entered the treatment mode X for X-rays, and then changed it to E for electron. So the machine he was working on was able to produce 2 different types of treatments. And during the time when he swapped it, the operator kept entering data, and the machine gave an electron treatment dosage with the X-rays. Does everyone know what a race condition is? Yes. Yeah, cool. And this resulted in the Therac-25 using the old treatment parameters with the new treatment mode, which we obviously don't want to happen. So what can we learn from this? Race conditions can cause critical software failures, and race conditions are insidious. They're difficult to find, test, or debug. In other words, we want to avoid them as much as possible. So how does Rust tie into this? Well, I believe that if TheraF 25, which was the radiation machine that was used in the treatment, had been written in Rust, this race condition would not have occurred. And that's because of Rust's safety features such as lifetimes and the borrow chip
What was it written in?
assembly. So
Tough.
yeah, don't write more security code. It's probably the good step forward. So why does Rust tie in? Because of Rust's lifetime ownership and borrowing system. So those are three keywords we're going to go over quite a bit today. So keep those in your head. So if you're too lazy, didn't read it, or didn't listen to me, this slide's important. So lifetime helps the compiler ensure memory safety by tracking how long the references are valid. The ownership is a system for managing memory that enforces strict rules about how data is accessed and manipulated. And borrowing allows multiple parts of the program to have temporary access to values without taking ownership of it. So in Rust, you can either borrow immutably, and you can borrow as often as you want, or you can borrow mutably and you can borrow once. So that's one of the constraints that the compiler places on. So I'm going to do a quick review of ownership and a quick review of borrowing. I'm going to start off with borrowing. So I'm going to start with ownership, sorry. Ownership is one of the key concepts of Rust that sets it apart from many other programming languages. It's a system for managing memory that enforces strict rules about how data is accessed and manipulated. Some of the rules of ownership. So there's a unique ownership. So each variable has a single unique owner. No garbage collection. So Rust uses ownership to manage memory. So when the owner goes out of scope, the variable is dropped. Moves. Ownership can be transferred by assignments or by passing value to a function. That's called a move. And there are no null pointers. So ownership enforces that a value always has an owner. This is one of the key facets of Rust, and it's something you're going to learn very early, very quickly. Quick review of borrowing. So instead of transferring ownership by assigning it to another variable or passing it to a function, you can also borrow references. These can be either immutable or read-only, and you can have as many of these as you like, or mutable. So read-write, you can only have one of these. The borrowing system ensures that multiple parts of the program can safely access the same data but with these specific restrictions. So we've covered ownership and borrowing, but what is a lifetime? So this is a talk about lifetimes. What is it? A lifetime is the construct a compiler uses to ensure all borrowers are valid. A reference's lifetime begins when it's created and ends when it is destroyed. And lifetimes can usually be inferred by the compiler due to Rust lifetimes division rules. We can also explicitly annotate lifetimes. So the borrow checker uses lifetimes annotations to determine how long references should be valid. And Rust may require explicit annotations when it can't figure it out itself. This is either because the compiler isn't perfect yet, or because it doesn't have enough information to actually do it itself. So we need to tell it how to do it. And the syntax we're using for explicit annotations is using apostrophe capital. So I've got a couple of examples on the next slide. So one is just with a single variable for the lifetime of A. The second one is with a variable with multiple lifetimes. This is also possible. In that case, it usually takes the shortest one. It's a little bit more complicated than that, but if you think of it as taking the shortest one, it's right 99% of the time. And the third one is a function which takes a lifetime parameter and two strings with the lifetime, and then returns a string with the lifetime. So for example, this could be a longest function where you're taking two references to strings and you're returning the longest string, a reference to the longest string. So when would you use lifetimes? Well, I'm going to go through the longest function again. So for example, here we're using the references to strings and returning a reference to a string. In this case, the compiler doesn't have enough information to actually figure out how long that string's alive without you telling it to. without you telling it that. So we need to explicitly annotate how long that variable is alive before we can use it. So here we've got the A, I can't highlight, sorry. So we've got the A apostrophe A, sorry, which is telling it that it's a lifetime. Does that make sense to everyone? Yeah, see a few nods, that's reasonable.
Does that mean when you call it that you have, so you've got X and Y, obviously you're going to call it with X and Y, and you have lifetime annotations where you called it? Or
So you're passing a reference
Yeah.
to X and Y, and you're saying the reference to X and Y is going to be alive for a lifetime of A.
right.
But you don't need to put that into the calling reference.
Okay. And can that declaration, that function declaration, exist in that format without the angle brackets part?
No.
Right, it's to say,
Yeah.
you need to look at, okay, thank you.
So I might just ask a question in case it clarifies for some people. What would happen if you took away the lifetime, so you weren't borrowing? So if there was no references, it was just ownership. Do you know what I mean? Like if you were to take just an own string, two own strings. Am I making sense or not really?
I haven't actually tried it. I think it would just work. So
Yeah,
because
but
you're
how would that change this?
okay, so you take out the angle brackets here. You take out your lifetime annotation here. You take out your lifetime annotation here, and you return. Is
But
that
then-
what you're asking?
Yeah, but then, like just to clarify, so if you take it without the references, the function would take ownership of both
Yeah.
values.
And then it would drop
Yeah.
them. once
Yeah,
they've been-
so you can't use them after. Whereas this way you can use them and then keep using them later.
So the function takes ownership of the scope of the variable if you take out the lifetimes. Because the function now owns those variables, once the function goes out of scope or once the inner scope here is finished, it'll delete or it'll drop that variable.
So this is how you borrow.
Yeah, so that the
Okay.
8% is a borrow.
Right.
Or
What's the A represent?
The A represents the lifetime function of life.
It could have been
What
named
value would A
ABC.
be?
Huh?
Like what value would A be to represent a lifetime?
It can be anything, like it could be A, B, C, D, E, F. It's just something that you're telling the compiler that it'll be alive for this long.
So are you borrowing the lifetime of X and Y, or are you borrowing X and Y themselves? Or are the lifetimes bound to X and Y? Like that?
You're borrowing X and Y themselves. You're just saying that reference is valid for a lifetime of A.
Okay.
and sorry, in that function declaration, the lowercase a, is that like in a sense, a generic parameter?
Yes.
Yeah.
And so you're saying it's the same, whatever value it is, it's the same here, and at the end then?
It's kind of a constraint, I think, is a good way to describe it.
Yeah.
So both live for at least A. So
So if I create a function called shortest, do I still use A or do I use B?
you can use whatever you want.
It's just a variable that represents.
But the lifetimes and all the arguments in the function plus the return value would have to be the same. So you could change them all to B, but you can change a couple of them to B.
You could do, it becomes quite a bit more complicated. So you need to say that your output variable, so you could have like A, B, C, right?
Mhm.
And you'd need to say that A and B live at least as long as C.
Oh, okay.
If you like, I can show you some code after to like
Yeah.
and where this would maybe I don't know what you have after this.
So
Sorry,
if I create a function called shortest and I reuse A, that A has nothing to do with that A for longest? I think, okay.
So I think of it as similar to a template in C++.
Yeah.
But I'm not sure if that's actually the best way to think of it. That's just,
Yeah.
I've done the templates in C++ and it's simple.
It's just like a variable name. You
Yeah.
can call it whatever.
Yeah.
Like a pointer for scope.
Yeah.
Kind of, yeah.
Which is very useful because when it goes out of scope, you can tell it exactly how it needs to be cleaned up.
Won't the compiler yell at you? Like say if we had A, B, C,
Mhm.
if we didn't ensure that C was shorter than A and B,
Yeah, so you have to tell it that.
the compiler
A
would
and
just be
B.
like, no, you can't do that.
Yeah, so the compiler will shout at you if you don't tell it that.
Cool.
The compiler will yell at you for a lot of things, but it's very nice to yell at. Like it gives you a very helpful. It's constructive criticism, rather than just criticism.
But also the IntelliSense is quite good too. So
I noticed that when I was playing around with it.
yeah, like it won't let you get that far a lot of the time.
Questions now?
IntelliSense in like VS Code or something.
VS Code, yeah.
Yeah. So, sorry, George.
So I'm sorry, I'm probably well behind in terms of developer understanding. So A doesn't actually have a fixed duration. It's just so long as the reference is A, then the duration will be whenever it's defined by its use, not by its value.
Yeah.
Okay.
So basically the compiler figured out.
So, but if you use the A again, like from my understanding, like the value of X and Y will be kept past the use of that
Yeah.
function now.
Yeah.
But you could reuse A in another function and it would somehow know to keep the value of X and Y there. Would it conflict if or rewrite if you assign X and Y to another function? Like,
So firstly, you're assigning a reference to X and Y.
Yep.
So it's the lifetime is tied to the reference, not to the variable.
okay,
I don't know if that makes sense.
it like, I mean, when you say the reference, just to me speaks to like location in memory, but
Yeah.
Other than that, I can read up on it. I don't want to hold up the meetup.
I mean, I think that if I'm correct, the A here is meaningful only to this declaration of this function.
Yep.
Yes.
It's saying you're going to give it two strings of equal lifetime.
Well, okay.
Well,
Minimum
might
is
not
is kind of a constraint.
Okay, so
At least this long.
okay,
And you return a string which is for at least that long as well,
right.
because you're returning a reference to one of those strings.
So in my mind, in addition to having the reference, it's not just a memory location, but you've got this additional piece of information about lifetime
Yeah.
that goes along with it.
Only a compiler time though.
Yes.
All gets.
Right,
all
right.
out.
Yeah.
Everyone happy? So basically that looks complicated. So to me, lifetimes are one of the most difficult things to understand in Rust, which is why I'm going to talk about it now. And lifetimes look complicated because they are, at least to begin with. So the key point here is just to practice and to try and understand it and to figure out what's going on. You will get there, it just takes time. So why would I want to use lifetimes? This is a pretty dense slide, so I'm not going to read out all of it. But basically, the first one is just reducing bugs and vulnerabilities. So lifetimes will help you write safer code, like full stop. There's facilitating safe abstractions. So by putting constraints on how references are used, Rust ensures that these abstractions are free from memory-related vulnerabilities. Kind of the same thing as above, but it makes it easier to work with in my opinion once you get used to it. And it's also a form of documentation. So your variables will be told how they live, and you can look at that and understand them, which I think is really great. So I like explicit documentation, like documentation in code. So I've talked a lot about how lifetimes avoid bugs. So let's look at some explicit cases. So firstly, it's a dangling reference. So without explicit lifetime management, it's possible to inadvertently create references that no longer exist. So for example, here we've got a string, which is heap allocated, and then we return a reference to that string. right? However, this won't work because once the variable s goes out of scope, the reference to it will just be pointing at nothing. So this wouldn't compile in Rust. So this lifetime check basically eliminates the whole concept of taking reference, which is very, very useful because I know I've screwed that up more than once. So
Constantly in Python.
Hmm?
Constantly do stuff like that in Python.
so use up to 3. So use after free is basically where you free up some data, so you drop it, and then try and use it. So in C, C++, I'm 99% sure that'll just crash the program, which is something we want to avoid because just randomly crashing is bad.
Or worse, it just keeps going.
Yeah.
Do you need to declare the S as mute on line 2 there?
I don't think so because we haven't assigned it to anything to begin with.
Right, yeah, okay. That makes perfect sense.
I think I'd need to double check.
You
that.
might need to set the type as well.
I assume you check this compiles, right?
This doesn't compile it.
This doesn't.
it's
Oh, but like
designed to
the
not compile.
type checks. Yeah. Yeah, I think that's Rust lets you get away a lot with this when you haven't initialized stuff because it does all the lifetime analysis. It knows you never use S before you initialize it, so it can kind of say it's fine.
Yeah. The Rust checker does some really cool stuff. So here again, working with the string. For most of these, I've just chosen strings because it's easy to let like a heap allocation variable. And then, so the scope here, when it goes out of the scope, it gets dropped. So we can't use it anymore, or but we can't print it here because it doesn't point to anything valuable.
You declared it outside of that scope.
Yep, but the thing it's pointing to gets dropped.
Right, okay.
So it can't, it will only let you compile if it can guarantee that it's valid code. Which I think that caught me off guard a couple of times as well. But yeah, so that's something that I've avoided. I'd like to avoid it. There's also double free.
Sorry. The thing in C++ is that you've just created this temporary and then pointed to it. And then theoretically that doesn't exist anymore when you get down to the next line, but probably it's still there in memory.
Yeah.
And so you go merrily on and potentially, it doesn't catch you until some other time.
Yeah, I feel like this would work in C++, even though it shouldn't.
Yeah.
It will work in C++. It's
Yeah.
great.
It's called UB, undefined behavior.
Yeah.
So there's also double frees. So for example, if we try and free the same value twice, so here we made 2 references to the same string. No, we're allowed to make 2 references here because they're immutable references. And then we try and drop both of those references. So this will give an error because S has already been borrowed. So that would have been dropped.
What is drop doing here? Sorry.
Basically deletes it cleans up the memory.
You said there could be multiple borrowings, right?
Yeah.
But only if it's immutable. Right.
Yeah.
Sorry.
So dropping R1 is dropping the memory from S.
Yeah.
Is that just how everything works?
Yeah.
Interesting.
Do you typically explicitly drop or do you generally rely on scope?
You generally rely on scope.
Yeah.
Could you also drop S? Do you have to drop the reference or can you drop the actual variable as well?
You can drop the variable as well, but
You typically would do it with the reference.
well, you typically just do the scope.
Yeah, cool.
Yeah.
So if you get the drop, then it's going to complain, is it?
If you forget to drop, it's just going to go out of scope. There's also other races. So the fast lifetime system helps prevent data races because you make only one type of immutable borrow. Sorry, you have one type of mutable borrow or several immutable borrows. So for example, here we're trying to reference the same data twice. That wouldn't work in Rust. That just won't compile because you can't have two mutable borrows.
You can kind of one mutable and one immutable, that's fine. So the moment you make a mutable borrow,
Yeah.
that's no more no more borrows.
But if you remove that, if you go out of scope with the mutable borrow, you can then borrow immutably.
Yes.
Yeah.
So it's just because if you have a mutable borrow and an immutable borrow,
Yeah.
you can change it with the mutable borrow and then rechange it with, and then read it again from the mutable borrow, from the immutable borrow.
Yeah. So that means once the mutable borrow goes out of scope, can you then mutually borrow? Because you only say you can only mutually borrow once.
Yeah.
Can you mutually borrow it? That borrow goes out of scope, and then you can't mutually borrow that again, even though it's gone out of scope. Or?
No, you can mutually borrow it again.
Okay, got it.
It's just there can only be one mutable borrow at a time.
Yeah, that makes sense.
And then there's
Sorry to be a pain. I'm not sure about the R1 and R2 thing from before.
okay.
I think that's valid because you're dropping the reference, not the. If you were to change the drop to be the dropping the string instead of dropping the reference, I think that would break it. Sorry, it's just like
No, that makes
sense.
sense.
Go off what you say just to like clarify.
Yeah,
that would work.
As in dropping R1 and R2 is dropping the reference to S on R1 and then dropping the reference to S on R2. Is that what you're saying?
So do you mind going back to the slide, please? Sorry to like jump in. Yeah, that one. Yeah. So
So
here,
we drop S rather than drop R1. And drop S rather than drop R2.
yes, exactly. And then that would be bad because you're dropping value that it's being referenced to.
Yeah.
But this is fine. This just small, but I think it's important to.
Yeah.
Okay.
So yeah, I make mistakes.
If you dropped S and then tried to look at R2, would R2 be pointing to nothing? Or something?
Yeah. So that's when all you have to do in this code to make it break is just change R1 to S.
Okay.
And everything. I assume it's just a typo.
And it just won't compile.
And it won't compile because you drop something that it's being referenced to. So you can't do that. Good. Yeah.
Only one left. So the last one, stale references. So that's basically saying that we can't return it with an old value. So we're returning the reference to S2. We can't do that for the same reason we had before, where we had this is going to go out of scope, so it'll be dropped. So we're returning the reference to the drop, which doesn't exist. So the compiler won't let us do that. I think we've already covered this, so I won't spend too much time on it.
The same as the dangling, right?
Yeah.
Yeah.
It's similar. It's just people call it different things. I thought. Yeah. So concluding, so we've covered what are ownership, borrowing, and lifetimes in Rust. Why should we use them? And some practical examples of how they help us avoid bugs. Cool. Thank you.
I wish Python was more explicit about its scope. Just looking at all your examples and being like, yeah, I've done that one.
I have a question. Would you be able to put the initial function back up there with the A's?
The longest.
Yeah, longest function.
That one.
Yeah, this is a problem that I come up against a lot in C++. I'm just wondering how this actually helps it. So let's say you've got X and Y and their references to two strings or whatever, and for some reason y is a dangling reference. Let's say y, you think that y is a valid reference, but it's actually it's not it's dangling. Does this lifetime, like, how does the compiler know that's happened, or is that what this is for? Is that
So
what this
firstly,
annotation?
dangling reference wouldn't be compiled by the time you get to that function.
Okay,
So the compiler wouldn't let you get to that point.
I'm trying to
What-
think how
that's
the
not
compiler
saying.
knows, but I don't know. I think I'm gonna be able to answer that question.
What it's saying is that because it's a reference, it needs to be pointing at something.
Yeah.
So it's telling the compiler how long it's alive for. And it's saying that, so A is at least alive for this long, and X is at least alive for A, and Y is at least alive for A.
Yeah.
So that means that our return type, because we're returning a reference to X or Y, is also going to be alive for at least A.
Yeah. So my question is, this is not dealing with what my question was. You're saying it would have been caught earlier anyway.
So but the compiler can't guarantee that the reference is still alive at the point that's being called by the function.
Yeah.
So you need to manually give it those guarantees.
Okay.
Does giving it a guarantee, like, does it actually supply those guarantees? Whereas if you didn't have A, then you could get a reference, a non-reference.
So this won't compile without the lifetimes.
There must be a way. No, I'm guessing there's a way that you can have a function that acts like a factory and creates something to pass back to the rest of the.
Yeah, absolutely.
So like you had one there, the dangling, that created a string, but then it was out of scope by the time you were going to be handing it back. Is it simple to just describe how
So
that?
I just wouldn't return a reference.
Oh, I can. Do you want me to talk about it? Yeah. So I think what you're talking about is called the build pattern. Basically, the way it works is you have a struct called your factory, whatever. Just correct me if I'm wrong here because I'm not super certain of the terminology. But with a factory, is like you create a factory and then you say like factory dot this thing is 1, and then factory dot this thing is 2, and then you return the whole, and then you like build the factory and that gives you a new thing. That's how it works, right?
You mean
in factories, in Java or whatever you're talking about? Is that how it works?
let's say C++, you can. Okay, well, some things in C++ which are like value semantics. If you create correct me if I'm wrong. I think you can create something. They have like return value optimization or some other different stuff. You can create something in a function and move it out of the function to where the return value would go, or you can kind of create something in a function, but it's actually being created back maybe on the heap, which isn't even in this function at all. But the idea of thinking was like, if you created, I don't know if this is how you would do it in Rust, if you can create a string inside a function, can you kind of hand that back?
Absolutely. Yeah. You just return an own string. So instead of returning like an AND string, you just say the arrow, and then you just say it's a string.
Okay.
But I think with the factory stuff, it's called the builder pattern. Whereas where you like, let's say for this thing for argument passing. So you'd say like argument passer new dot takes value, and then you give that dot takes other value, this and that, and that's all one thing. And the way that works is it takes a mutable reference to itself and it returns a mutable reference to itself.
I think I was over egging the pudding when I mentioned factory.
Yeah. Sorry, hopefully that makes sense. Yeah.
So you can just straight up just return something normally.
Yeah, I think.
So
did you have an
that
example of that on the slide? I think you did somewhere.
so, because most of this was just pointing at the bugs.
Okay.
So let's say here, if you just return S and return the string, that would just return another string.
Okay, great.
Yeah, so ownership can flow both ways.
Yeah.
You can't use it after you give away ownership.
Yeah, got it. Because I was kind of getting the impression that you kind of need to start some globals and then you kind of like
Yeah.
hard to get things out of
Yeah.
function.
That does happen sometimes, for sure. But especially for beginning, I find everything, just make everything owned. There's a way to turn it from a reference into a known value, which is called cloning. So you basically duplicate the memory. So that's how you can get an owned value from an immutable reference. But that creates a copy in memory, so that has a cost of memory allocation. But yeah, you can do that for sure.
I get the impression that the compiler will just give you like a fairly good, like you can kind of let the compiler teach you the language almost, it seems like, from the slides you've shown.
Yeah.
That's cool.
So I've learned a lot from the compiler.
Me too.
I guess I've got a question. So like you mentioned, you know, with Tharic 25 or whatever, like if you were using lifetimes, that would prevent that. But like if you are like a complete noob and you don't really understand lifetimes properly, surely you could still make a mistake that results in a problem, right?
I think you can still make mistakes. I don't think that mistake would.
Yeah, I'm with you there. I think
Like I have made logic bugs in VS Code.
Yeah, like of course, you know, you could, you know, if you have like add function or whatever and you've got like X and Y and it's like if X is 2, you know, give the wrong answer or whatever, like sure you can make logical mistakes, but like yeah, I'm just trying to understand if you don't understand how to use lifetimes properly, then can lifetimes still save you from yourself? Like
In my experience, yes.
right.
So if you don't annotate the lifetimes correctly, either it doesn't make sense in the compiler will go this is feasible,
Right.
or it'll raise an error somewhere down the line because it won't be able to figure out any feasible solution to that.
When you say raise an error, is that a compiler error?
Yeah.
Somewhere down, and you have to track down what's going on.
yeah, it's very good though at saying this is where the problem is.
Yeah. Okay.
So just to clarify, so what you're asking is, can you make an error in how you write your lifetimes so that it breaks the code? Or
Well, so then you get an uncaught like runtime problem, I suppose.
I don't think so. The compiler is overly conservative
Okay.
for the most part. I don't know. If you
So if I say you can't, somebody probably will. But like I haven't yet in like threats of being pretty trying like to do stuff like that. So
Is it basically like if you don't use the lifetimes properly, like it just won't compile, basically?
well, think of lifetimes as like a constraint. And then if you don't give it a feasible region for the constraints to work, then it's not going to be able to compile because it can't find a solution for that region.
So Rust's guarantee is if you never use unsafe, it will always compile correct code. So it will never do use after free, double free, that kind of thing. It'll give you a compiler error, but it will never output something that is wrong. Yeah. That's the guarantee that you get.
But why would double free cause issues?
I don't really know, to be honest.
OS. Well, what's the OS going to do if you sorry, memory that doesn't already own?
I know it does have, there are like bugs caused by double free. I can't tell you why.
So let's say I only want to write immutable code. How would that look? Like, will there be a lot of ampersands in there, a lot of inverted commas? Like, what would the code look like if all I want to write is immutable code? I just want to copy.
Yeah, that's cool.
Or clone.
He does like Haskell.
I like closure.
Oh, sorry, is that the wrong one?
Haskell is cool as well. I don't know how to write it. So
That really depends on your style and how you code it up yourself.
I'm just wondering about the syntax because all the ampersands and inverted commas are confusing. So
Yeah.
so I'm just wondering, what would the code look like if I just want to write immutable code and I don't care about memory? Just want to copy all the time.
In that case, you can just start play on everything and make copies all the time.
Okay, so I just put everything.
If you don't care about memory or
Yeah.
forms, yeah.
All right, and would I need to use the ampersand for anything?
Nope.
No.
You don't need to use it. It is just much more efficient.
What's the ampersand doing again?
Reference.
Is it relatively simple to say, so where you had the longest and we had lifetime reference that was the same tick A for X and Y.
Yeah.
If you were to change that to have two different lifetimes on the X and the Y.
Yeah.
And then you had to obviously do something to say what your result lifetime is going to be. Is it easy enough to say what that would look like, or is that complicated?
I think it's easy enough.
I mean, for a start, would we have angle brackets tick A, tick B?
Yeah.
Right. And then
So
we could,
it will get a bit wordy, but
and then we could have Y ampersand tick B.
yeah. I think you'd need a return type C as well.
Yeah. Okay. Yeah.
And then you need to specify that C is at least as long as A or B.
So where does that? Can't think of the word. Like, is that part of the function code? Or it comes in between the function declaration and the body of the
That
function?
goes in between the function declaration and the body.
Right.
So this is getting to the limits of what I've done.
Sure. No problem.
So I'm pretty sure it was between the function definition and body.
For the
Lifetime, so like X colon C, to say that X is going to live at least as long as C.
yeah, I mean, I actually don't really know, to be honest. So
Okay. Yeah, you won't use it very
yeah,
often.
but
Right.
I've done a lot of Rust and never done that. So I think that's mostly if you want to get really, really high performance. For me, what I would say my biggest advice for learning Rust, don't play with the references, or play with the references, but if you can chuck a clone somewhere, do it. Don't worry about it. Like that, Rust makes you make it explicit, but it's not the end of the world. So just, yeah.
And like eventually the thing that you cloned will go out of scope and then that'll get deleted. So then
Yes,
it's
yeah,
not super memory.
Yeah.
You're not going to get a memory leak.
No, it just makes, all the clone does is make it explicit that you are taking some memory and making a duplicate copy. So it's inefficient, but it's fine usually.
Is there a relationship between threads and lifetimes? Like with the whole two mutable references thing, you can't have two mutable references. Is that enforced in part by lifetimes, like representing threads or something? Or like how do you essentially have like two asynchronous processes go on and not access the same thing in a mutable way at the same time?
So that's what the origin is there. The following is there, so that you can't access, like you can't have a piece of data change while another shows a mutable reference.
Okay.
So I'm not quite sure how it does that, like how it actually implements it, but I know that's why it's there.
I was also thinking this. So if you had code, you just created two different threads, and it looked like, you know, reading the code that you only have one mutable reference, but actually two copies of that thread. There's two threads. The compiler just says, "Oh, you've got a thread here. You can't do this code," or like, what's going on?
It won't compile.
Okay.
So it knows how many you will have, but like at the time. Oh, okay.
Because it can only have one mutable reference at a time.
What if you use .copy?
Then it's not the same data.
Separate objects.
Yeah,
So
yeah,
it'll
yeah.
change it to, so did,
Oh, yeah, I see. I see why that you couldn't, have that problem.
so the way you would do that, like if you wanted to have mutable data that multiple threads access, is you have something called a mutex, and you have to require the mutex. So you wait. So in this, your Derek example, it wouldn't work because one process would have to wait for the other one to finish writing it and give back the reference before it can do anything, including read. Can't.
Yeah.
In some languages, if you had a string, it's allocated on the heap and the actual variables are pointed to memory. And if you copy the string, you're only copying the pointer to memory. And then sometimes you got copy on write. So if you change something, now you've got a different pointer and different heap location. Is dot clone or whatever in Rust like a deep copy or?
It's a deep copy. So what you're talking about with the copying, that would be a ref cell. That's a reference counted. So every time you make a copy, it increments the counter, and it will only free when the counter gets back.
Okay.
So we've only looked at like strings here. Like if you were to, I don't know much about Rust, but if you were to have something like methods, is this might be related to the decopy thing? Like if you were to call a method that then changes the header within it, how does that work exactly? Like is it kind of like some languages where it's like, you copy, but the stuff behind like one layer, like the other way is like still the same reference? Sorry, not sure about this question.
Not quite sure what you mean. So
Sorry
you're
about
saying
that.
you have a this.
You mean like if you had a class and it's got a string in it,
Yeah.
or maybe it's got another structure inside it and that's also got a string in it further down?
Kind of, yeah. Yeah, I mean, I'm kind of wondering if it's any different in that case.
Don't think so, at least not in the use case. So you might need to correct me here.
Are you talking about a class that modifies itself? How does it do that?
Essentially, yeah.
Yeah, so you just take an unmute self. You just take a mutable reference to yourself.
Okay.
And then as long as you say that the class, when you define it, it's mutable, you can give out mutable reference and then it runs it and then it gives back. So it's borrowing a mutable reference, so nothing else during that time can take any other reference. But then once that code's done, it gives back and it changes your code. Right. So does that make sense?
I think so.
Yeah.
Yeah, so back to my immutable for everything. So would the code be actually what happens if I don't use the inverted comma? I just write it like I'm a Python developer. I don't use all that ampersands and commas. I just write a str. Would that mean anything?
So you can just cut this out. So this wouldn't work because you're passing the reference to it, selecting the shortest reference, the longest reference. So what you would want to do is have like x is just x, y is just y. You return a string.
Okay.
But you would then when you pass something to your function, you would have like x.clone, y.clone.
Okay.
Yeah, so without the ampersand, you're transferring ownership into the function.
Yeah.
And then it's not coming out. I guess you could then transfer it back out of the function just by, having X or Y at the end.
Yes.
But I've lost my train of thought there. Never mind.
So I was going to say, if you got rid of all the references, so it was just longest, then X, Y, effectively what you do is you take two strings and you free up the reference to the shortest one. But if you want
two copies, right?
You do two copies. So you'd free up the reference to the shorter copy.
Yeah.
And pass out the longer copy.
Outside of the definition. Okay.
Oh yeah, okay.
If you like, I can hook my laptop up and write some code to demonstrate what we're talking about. But that would be useful.
I think that would be useful. I don't know if anyone else does.
It's all right. You know, with all your stuff, I don't want to sure. Okay.
Thanks, Kai.
Separate question. Can you return tuples in Rust?
Yes.
You're saying with the function, I mean, you're about to show this, sorry, I shouldn't.
Oh, it's okay.
But like when you call that function that's like just taking X and Y and returning the string, is it, do you, when you call it, do you just do X dot copy and Y dot copy? Is that what you mean? Or is it implicitly copied when you
take a reference?
when you pass X and Y and when it's not a reference?
Okay, well,
In the
what
signature.
it'll do most of the time, unless you explicitly say it'll take ownership of those two strings. So it'll do it fine, right? You can never use those strings again.
Yeah, okay, so that is what we're
Well, I'll start with this.
So it's like only one variable can point at that location in the heap. But when you pass it into the function, if you don't use the ampersand, you're no longer borrowing it, you've transferred ownership
Yeah, you've
of that point
made
to the
it-
heap. That variable now owns that location on the heap,
Signing a variable.
and then you can return that variable, and if obviously that another variable is equal to the thing that the function has returned, you've now put ownership on that variable. That is now pointing to that location, and it's gone everywhere else. But if you just consume it within that function, then it's gone everywhere.
So yeah, so like it's sort of the inverse of what would happen if you did that in Python, right? You had the global scope, and then
Yeah, and
Yes, yes.
anything commutated anywhere.
yeah, you can pass it into the function and it's still in global scope.
Yeah.
Thing. Yeah, you wouldn't even include it in the function signature, right?
Okay, so can everyone see this? I'm gonna blow it up so it's bigger. Much bigger.
Alacrity.
Yeah, maybe increase the DPI or something,
Put it on a plane.
or lower the resolution.
Control plus.
So no, I don't want it. Okay, but everyone see this? One more.
Yeah, it's pretty old.
Thank you.
No,
Yeah,
it'd
I can do this. Let's go. Not that. Everyone see this?
Great.
Beautiful. Okay, so we'll start with your example. So if we get two strings, right? Now Rust is complicated because it's about 5 different strings. So that's
not complicated.
you'll learn why. To start with, we like the capital S string that I'll show you. So if we have like X equals string from let's say hello, and then we have let Y equals string from hi. So I've got a bunch of you'll notice Rust analyzer. So if everyone doesn't have that, it does that. It gives you the type information. And it's also because I've got arrow highlighting on, it's going to give me a bunch of errors. But then we'll make a new function. We'll say longest. Yeah. And we'll do this. This is the simple way. So this is how you should start. So we'll take two variables, a string and another string. Oops, sorry. Y is a string, and it returns a string. So what is this? So we just say if x dot len is greater than y dot len, we do x else y. Okay, and then we just run this. Say, we'll do even better. This macro, I've been using Rust for 3 or 4 years. I only just started using this macro. It is amazing. Use this all the time. So you just say dbg exclamation mark, and then we can say longest of x and y. And then if we,
What is DBG doing?
Yeah, debug, right?
yes, it's the same as it. Basically, it's a way of just doing a debug print, and I'll show you what it looks like. It's very nice.
Kind of fantastic accident with the bang at the end. Like you're like, oh god, debug.
Yeah, see, so what it does is it gives you the statement, and it gives you what the value is.
That's cool.
So is everyone cool with this so far? So this is the basic way.
So then if you debug X again on line 5,
So I'll just
Trying to bang's just a macro, is it? It's just like a
so
language syntax.
does anyone know how to? I'm gonna put some
Close.
Oh, just I usually make. Do you want to put that up on the right hand side of
on a
the?
new tab or something.
Yeah. So make a new terminal.
Yeah.
Like just add a terminal.
Yeah.
Doesn't matter what it is, as long as it's another terminal. All right. Now drag the first one up. Yeah.
Ah.
This is how I always do it. I don't know how you're supposed to do it.
just
Okay.
use
Whatever. That was solution.
Right, that's the
Is everyone cool with this?
Yeah.
Now, if we try and
At that point where you come sorry, you haven't called longest, but if you had have called longest at that point.
Yeah.
X and Y are gone, is that right?
Exactly. So now, if you look,
Oh,
it's cheating a little bit because I got the inline errors, which I am very handy, but probably not for this.
Oh, you can drag the bash thing. You can drag that to the right. It'll make a split screen.
Yeah, but can you see it's 2?
Oh, sorry. Yeah. Never mind.
That's a good idea. Sorry. So look, Rust. So this is why part of why I love Rust. So it says, if we look at this, so this is our code. So we're trying to print X basically after longest has already taken ownership of X. And now it might be the case that X is the longest. So actually we can show, I can show you. So Y is the longest, right? Y is going to be returned ownership, but we still can't use it because as far as the Rust compiler is concerned, if at any, because it's overly conservative, if at any point it could possibly not make sense, it says it's not allowed. So look, here it says we'll do like that. So we'll say yes, the move occurs because we're taking a string and it's giving ownership here. And it's saying if we want to use Y after this, we have to clone Y. So if we don't care that the Y we give is the same Y we get back, we can just say Y.clone. And that'll work. Now it allows us to do this. It's all good. So does that make sense to everyone? Because this is really tricky. So if this doesn't make sense, please tell me. Everyone good with that? Yep.
But I guess it's when you're actually assigning like the result of your longest to a new variable, then the lifetime passes to the new variable.
So we'll say we'll do that. Like that. That's what you mean, right? Yeah. So now,
Still Y? No.
so long, this variable takes both X and Y, but it takes Y.clone. So if I just do this, longest takes ownership of both X and Y, and then gives back a new ownership to long. So X and Y are no longer allowed.
What happens if you throw a logical error in? So like, what happened if you put high in? Because obviously there's no. Oh no, it's just going to return Y there. But like, if we had like else if Y.long greater than X.len, and so instead of just an else, if we had an else if checking the reverse rather than giving a default, because that's default Y, right? Like if they're the same, it's going to give you Y.
Yes, correct.
But like if we just put else if Y.len is greater than X.len,
Yeah.
and we didn't have an equality condition.
So let me give you a X, right? Let's say we always return X. Hopefully this makes sense. Even if we always return X in every case, longest the function still takes ownership of Y and it doesn't give it back.
Oh, sorry, this wasn't really an ownership question. This was more like, what's the default return going to be if you?
Oh,
It won't let you. So
It will just
the return type is string. So you have to have X or Y. So you could drop the else and still have X or Y.
yeah. So if I do this, is that what
Yeah.
so now it's saying it doesn't work. And if I run the thing, it'll give me a proper error that says, yeah. So this is the Rust compiler is really helpful. So it says the tuple with nothing in it just means it's kind of statement. And what it wants is us to say something at the end. And it could, so we'd have to change this to return instead of just an implicit return. Then we could say
how does it even know that?
magic.
Yeah, it is.
No, so so it does type analysis because the return type must always be string. But when you say this, it's essentially the same as saying
Else return none.
return that.
Yeah, null or whatever.
Because when it hits the end of a block, it does a block that doesn't return anything. It's this tuple type. Is that everyone cool with that?
Right, so it solves it by constraining what.
Yeah.
Yeah.
So when you start involving the inverted commas,
Yeah.
you don't need to clone.
You still have
Did
to
you cover that
clone.
already, or were you?
But yeah, no, we're about to get to that.
Okay,
You don't have to clone. So if we change longest to be like in Kai's example, so we said we'll give it a lifetime. We'll call this one different. We'll call it B, just to be weird. So we'll say this is a reference to a and B str.
Excuse me,
Yeah.
is it possible to use ref without lifetime?
Yes.
Okay.
Well, sorry, actually, I'll show you. After this.
Why do we use str instead of string now?
So this is the thing about Rust. Rust has like 5 different string types. So a string with a capital S is a heap allocated owned string. So on the variable is just a pointer to on the heap where you have your actual string value, and an str is a stack allocated reference.
Like a C string.
Okay, so yeah, kind of. Except in Rust, there's a lot more better strings than one C. Like they're not non-terminated ever. But yeah, so and now it's complaining because it was saying we expected a reference to a string, but it gave us we gave it ownership. So where did you? Yes.
Borrow.
Yeah. So you just need to say and X and Y.
Mm.
And now that's all good. It's happy with that. So it's the same code.
So can you just remove all of the lifetime stuff?
Yep.
please?
So now I can actually just get rid of that entirely, and you will notice
Oh, it's implicitly done it.
it's implicitly done.
Ah, because I've compiled, code without
Yeah.
like.
So I have in my, if I to,
But then we have different.
I have this one. Rust Analyzer inline hints. You can basically say always show lifetime hints for Rust Analyzer.
Right.
And that gives it this. So this
Yeah,
is just the
okay.
compiler telling
Sorry, what was Elysian? Elysian?
illusion.
What? I've never seen that word before in my life.
So it's basically saying when you the lifetime that it guesses. I think I might be wrong on this. But it's basically saying give a name to all the lifetimes it guesses and show them. So it's infer lifetimes.
Do you need to drop the ampersand on the stir on the end there?
No. So this is where we say I've lost the
Terminal.
Okay, so yeah. Oh. And it will tell us. So I mean, in theory, this would be like we know this code works, but the compiler is overly conservative. So this is why this goes back to what Kyle was saying is sometimes you need to give the compiler hints. And what it gives us actually here, this suggestion, is exactly what was in the slides. So it's basically saying it doesn't know for sure that in every case it's going to be the lifetimes are going to match up. So it needs to do it. So that's why we need the AND A, or the tick A and the tick B. Is that making sense ish?
If you change that now, because we've got lifetime X and Y. Oh no,
Yeah.
we haven't.
Yeah.
We haven't really, have we? Or
No, this it's kind of grayed out. This is not.
Yeah.
This doesn't actually exist. This is what the compiler is trying to guess something.
yeah.
If I'm not very smart at programming, and with that longest call, you have to like pass it a reference. Is there a way to like make the longest function, like you pass it X and Y, but it takes a reference of them?
That's what borrowing is.
That's what this is.
Huh.
So, are you saying you don't?
I
You
figure-
don't have to put this ampersand here.
Yeah. Is there a way to
Yes,
without having to explicitly pass the
Yeah.
reference to X or
But this
reference to Y?
I'll show you. This is going to get complicated.
Cool. Sure.
I might get that wrong as well. So what you can do is you can say, does that anyone know what a trait is in Rust? Yep. No. Okay, I don't expect you to.
Yeah.
Do you want to say what it is?
It's kind of like the interface.
Yeah. That's it. It's an interface.
Oh,
So
okay.
there's a bunch of standard library traits. One of them is, let's see if I get this right. No, I'm just going to get Rust Analyzer to tell me. Okay, so instead of taking that, what you would do, this might actually work. X as ref.
Okay, cool.
And then this will give a string. So then we can say like let X equals as ref. And then to oh, sorry, we need to say implements as a ref. Okay. And then here we can just say dot to string. That's how you would say, and then we can give it this. So that's how you can take, this is how you can design Rust APIs, where you can give it anything. You can either, so this can either be a string or a reference to a string, and it gets the same thing.
Can you pretty good unpack a little bit?
Of course, yeah.
The function check, like you got X and Y in the parameters.
Yeah. So,
and there's X and Y in the function.
yeah. So this is saying as ref is a multiple trait. And if you hover over it, it'll give you a whole thing about it. But basically it's saying any a trait that says for any type, give it a reference to the type. So for answer, it gives just an answer, and for a string, it gives an answer. So it's basically a way of kind of like shrinking. You accept more things. And then this in this echo brackets here, this is generic parameter. So we're saying we want anything that can turn into a reference pointing to a string. So we can actually make our own code, like our own class that can turn into a reference to a string. And then we can put that in X. That can be X if we want.
So does .asRef, if you've got a reference to a string, that just return, so x.asRef str, like str, if it's just a str,
yeah,
it'll just return X, and if it's a uppercase string, it'll return the reference to
So
a
can you put x.asref.asref.asref?
Yeah.
Okay, that makes sense.
And like as soon as it gets down to a str, it's gonna basically just
Oh, it doesn't like it.
It's not happy, so I'll just say
Make it. Okay, yeah, right.
so sometimes it'll get confused and you just have to give it a nudge. So it's just
Cool.
just like with the lifetime, sometimes you have to be explicit about what you want because it doesn't know for sure what you want.
So do you see this sort of pattern quite a lot?
So I write a lot of APIs, and yes, this is good, like easy to use stuff. You don't need to know this for sure. Just take owned everything and return owned everything. Use clone wherever you can.
This seems, I'm not understanding something.
Yeah.
And it seems a little surprising compared to what very minimal I know of Rust, right?
Yeah.
So before we had the function would take these, if you weren't using refs, it would take ownership of these X and Y, and if it didn't hand anything back, then they're gone, right? So does this function still own X and Y? And then we've got this let X again. Is that mutating or is that creating different variables?
So yeah, so it does actually. So here's the important thing. So you'll notice if we try and write X, it's fine with that because we give it a reference X. But if we give it Y, it complains about moving Y. So it still takes ownership, but you have the option to borrow. So maybe you never need Y after this, and this is fine. You can just say take whatever I don't care. It depends on your case, right? But yes, so the ownership still applies. It's just saying it gives the option where if you take a reference, it accepts reference, but it also accepts values.
And then when we get to the let X part, what's happening there?
Okay, so basically we're saying, so we have this thing. Get rid of this. So we have this thing. We're saying we want. We have a variable that we know. So the impl asref gives a compile time thing that says any type that can turn into a reference to a string. So we're just saying X is the string, and we want to call the asref function on X. And we know the asref function will exist because that's defined by this. So if we have a look at this.
I'm fine with the x.asref part, but on the left-hand side, is this creating a different X than the X that was?
Oh,
It's just a shadow variable, but
Yeah.
because you're allowed to have the same
name as another variable if it's a different type.
Oh.
Yeah.
Sorry,
Yeah, but then
Sorry.
No,
gone.
it's not mutating.
it's never mutated.
No, it's creating a new thing.
So it's
Ah.
a variable that's a reference to this string.
Yeah, it's stupid.
Thank you for bringing it up.
I don't know why that.
That wasn't
Well,
it looked very rusty.
Yeah. So yeah, that is actually a big book on which I've done before. So, yes, thank you for pointing that out.
functionally, toString is the same as the clone.
It is, yes,
Yeah.
except it's explicitly for
It's
turning
for a
an
ref,
answer to a
not-
string.
String. So you could go from a string to a ref to a string, which would be the same as a string clone. So you could do clone on that string.
No, you can't because so the clone takes the thing and returns an own value. So in most cases, you can do a clone. In this case, because strings are handled weirdly in Rust, you need to say the .to string.
Oh yeah, so so you've gone to
But
string, but you could
it's a
put
clone.
another dot and put clone after that because it's
Oh, yeah.
a string and you
Yeah,
can clone.
and then you'd just be copying twice.
You think it'd be smart enough to just say that you're being silly.
You might
there.
you can never like depend on.
Yeah.
But yes, it will probably say this clone is done and get rid of it. Actually, maybe if we
Let's try that. Yeah.
Oh, wait, you know,
What's Clippy?
Clippy is this wonderful tool. Basically, get it to yell at you about a bunch of different things.
Ooh, that's what I wanted.
This was written by. I feel like this was written by millennials. And it's good.
Yeah. I don't actually know how to get the link, but I do know it's needless.
Ooh.
Can
Can you do all? Just like star or something?
Yeah, you can. I'm not really that good at Clippy, so I don't know what the syntax is. But yeah, you can get it to say like this here is unnecessary. Remove it.
Because I imagine like if
Cool.
you set it to optimize like high,
Yeah.
it'll probably
It'll get rid of it. Yeah. But,
Yeah.
so Clippy is more for syntax stuff. And it will say like, oh, you don't need this or.
Like compile time linter almost.
Yes, exactly. Yeah. So what I do is, because I'm a masochist, I basically just set Clippy to deny everything that is bad. And there's this huge, I don't have network and it's not important to get network right now, but I have, there's this huge list of all the different Clippy lists and for every one, it'll give you, there's an error code, it'll give you an example and it'll like tell you how to fix it.
So does Clippy come with Rust when you
So
install
when
it?
you install Cargo, you get, so there's a bunch of different Cargo commands. There's Cargo like run, which just runs your code. There's Clippy, which like checks your code. There's Cargo format, which formats your code. I have it set up to format on save, so it's not going to do anything. But if we do that, save without formatting, thing, like formats for us. Yeah. So Cargo is not just build tool; it's also got like the linter and the format and everything. That's in it. Free. So yeah, if you have Cargo installed, you have all that.
Does every, oh, sorry.
So I want to do all that.
Yeah,
Like,
it's complicated, like very hard to understand.
I was under the impression,
Yeah.
wrong or right, that if I want to write things immutably,
Yes.
I don't need to use the ampersands. I'll just use the tick and it will automatically close for me.
I think no, you just want to do it like this: X string, Y string, and then you get rid of this, and then we'll just say replace it. And then that's how you do it. And then you can just say X dot clone here.
Okay, well, yeah. What if okay, so what does the tick mean then? If the function, the longest function, we put a
Yeah,
tick in there, what
so
does that?
that's with the like.
We're not borrowing here. We're
Yeah, so-
transferring
Yeah,
ownership.
this is ownership. So this is you have complete ownership of the value because we're cloning it.
So you can't access it afterwards.
So I have to, so is this the way I have to write if I?
Well, there's two ways, right? You could take the immutable reference and then return a known value. So that's what we did before, where it's if you say like the longest for and X and Y, and then we have to do the ticks then. So and A.
So that means it's an immutable.
immutable reference that lasts at least that, and then this would return an owned value. So this would make a copy. So like, because I assume what you're saying is I don't care about memory management. I just want it. This is how you would do it, probably, unless you want it. If you wanted to take ownership, because maybe in some cases you don't want them to access. So, for example, one thing that's really cool about the drop that was shown earlier is that all it is a function that just takes ownership of this back.
So you could implement your own drop quite easily.
Yeah. So if we want to make our own drop, let's make a drop for just strings.
But so then you'd need an anonymous, sorry, not anonymous, a generic on your drop so that you can accept any type.
Yes, exactly. This one. And we can just say, how this works. Yeah. So that's how we can.
Yeah. Okay. Cool.
That's all it does essentially. Is it just takes ownership and gives it back, and that's how you bring memory.
Is the actual drop with a D? Sorry, capital D or lower D?
Lowercase. So all functions are lowercase. Snake case.
So you can just overwrite.
Well, you haven't inserted it in. You haven't used prelude.
Drop is mem drop.
Yeah. Okay. That
No, that's a problem.
So sorry, that's important to say. So if I were to say at the top, then it would probably complain.
Yeah. Okay. There we go.
Because it defines it multiple times. But yeah, because it's in a module. That's the main point.
That's interesting. So can you use aliases when you're importing a module?
Yeah, absolutely.
Okay.
You can say
Cool, because that
use
would be annoying.
Drop as the drop.
Cool.
It still gets an error because we dropped it, but it's great.
In the longest function.
Yep.
If you just don't have the lifetimes, you're just taking X string, Y string.
Yep.
So it's something that wants to take ownership. You can't call that with references, is that right?
No.
And there's no such thing as a ref in.
No, I think that's where you would use the impl-as ref from earlier. So that's saying you can optionally accept a known value, but all you care about is the reference. So that way, if they want to just give you ownership, they can. But if they want to give you a reference, they can. It's up to the user. So that's mostly for library code. So if you're writing a library, that's where you would see that mostly.
And is there, so with a Pascal background.
Yeah, I've got no idea of Pascal, so just.
Is there any way to say I want a function that will only copy?
It's a great question. I think, this technically is, right? This is a function that will only copy. That's what we have here, because we're saying we're taking a reference, two references and returning an own value. And to do that, you have to clone.
You mean a copy of the arguments rather than return value?
But this is more efficient than cloning both because you only clone the result.
Yes. And then you can do more complex lifetime stuff that I honestly don't know well enough to like present on.
Right, because you don't have to clone X and Y here. You just immutably look at the
So this goes back to Kai's example, right? If you just want to return which one is bigger, you can just say return in the and a string. That works. So it's all about
it's just passing the borrowed reference onto long.
Yeah.
Oh, okay. I get it now.
But so the reference, you've returned either X or Y to long. So now the variable long has a reference to, but it's immutable. So long is borrowing.
Yeah, that's a good question. Okay, I think I get what you mean. So now if we want to print long, that'll work. So just do this. This works fine.
Yeah, but if long was
So I think this is what you ask. If we drop X and then we try and print long again. We're saying we can't drop X because long is a variable, is potentially referencing X.
Yeah, I was thinking more, you've got two references to X.
Yeah.
You've got long, which is a reference to X.
Or
And
X
you've also
yeah.
got the X inside of longest, but it's okay because they're immutable. But if they were mutable, long couldn't be mutable because then you'd have two mutable references to X.
I mean, if
Not at the same time, right?
If you change the signature so that X is mutable and the result is mutable.
But that X is, so what you're saying is if I did a mutable reference to X.
You have to make that mutable.
Yeah.
And then, but long can't be mutable because I don't think, or can it? I don't know.
So hold on, I'm just gonna
Oh, power.
plug in my laptop. But so basically, because a mutable reference is always better than an immutable reference, you can give a mutable reference in place of an immutable one. Because you know you're the only person accessing the data because you're the one person. You're the one point at which you have a mutable reference, right? So this works fine because what it does is it turn like.
Yeah, because the signature of the function doesn't take a mutable.
You're saying you couldn't return a mutable reference because y is not mutable.
No, I'm thinking because so long is like borrowing X essentially through the function.
Yeah.
But X inside of the function is, if you make it mutable, is mutable. But then maybe because it goes out of scope, it doesn't matter anymore.
So just to clarify.
So if you make the result, so longest, if it takes a mutable A and returns a mutable, sorry, if you take a mutable X and returns a mutable borrowed string, and then long is mutable, that shouldn't be allowed because they're both pointing at X. So there's two mutable references to X.
I think
Not at the same time.
It takes ownership of that mutable reference by giving it here. But
if you come back, let's go.
Yeah, and tick A, right? You got to remember. So the smallest, so anti K is a constraint, and because we're saying X, the smallest, so it's like a Venn diagram kind of. They're saying like the smallest lifetime that exists between X and Y. So X is an stir, and Y is an answer. So A is the smallest in between an stir and an answer, which so it gives a immutable reference. So X here is going to be an immutable reference, even though you give it a mutable reference.
Yeah, but in the function longest,
Yeah.
if it takes mutable
Like this.
Yeah.
Yeah.
And returns mutable.
Yep.
And you make long mutable. Oh, I guess Y would have to be mutable.
Y is mutable. So I can do that. Is that when you do Y as well?
And you need it in the And then if you make long mutable, what does it say?
It doesn't need to be mutable. So yeah.
So
if you
okay, so
long,
I mean
it's just a reference.
but this is still allowed.
Yeah.
Okay.
So you see, because long could change to a mutable reference to something else.
Cool.
Yeah. So, but you couldn't.
But then, but X is mutable and is pointing at the same location on the heap, and long is mutable and pointing at the same location on the heap.
So there's two different. I think this is the confusing thing is there's the let mute and the and mute. These are two different things. So the mute says you can change this variable to be something else later, and the and mute is saying you can change the current reference data. So what that means is X could change to a like hello to, right? That's allowed. So I don't think I'm making what my case super.
So what if you
Is it correct? Sorry. Is it correct to say that X, even though it's mutable, doesn't have a reference to itself yet?
Whether the reference or the variable itself is being stored.
Yeah, so again, you're getting a mutable reference. So you can't change a buffer.
so if you were to set long to a new
Yeah.
value without shadowing it
Yeah,
and then print X, what happens then?
so you're saying like if we set long to the
Yeah,
and then we print X.
yeah.
We can actually do this.
Or I guess you need to do string from new as reference or something.
Yeah, you can like give it a as mute. I don't know if that'll work though because the borrow checker has limitations.
Cool.
No, that works. Okay.
All right.
And what did you want to print? X.
That's it. Yeah.
Let's run that. It's hello. So,
Okay. Because it's a different reference. You're no longer pointing at this. Yeah. So, okay, I understand. Got it.
Is anyone else confused about what just happened? Yeah.
No, I understand now.
I don't think.
Yeah. Yeah, is that anything else? I know we might be out of time. I'm not sure what the deal is, Shelby.
I mean, there's more stuff.
I don't know, is there?
I want to clarify something. So let's say we remove all the mutability stuff.
Okay, that
Um,
might take a while to say.
okay.
You keep talking, no, keep talking.
But, so like the borrowing and ownership stuff. So if we keep it as like that. What was the borrowing and ownership that's happening? Is the
Yeah, so longest borrows X and Y, both of them, takes immutable reference to both of them. And then it gives back is it returns. It returns a immutable reference, which is at least as long as the shortest lived reference out of X and Y. So I think if we do this right, if we make a new block, we say we put it all in here. So what we're saying is X, because X can live to the end of X can live down here, but Y can't get to down here. It's declared inside this block. So the and tick A will be until the end of this curly brace, because that's the point at which Y is no longer valid reference. Does that make sense, kind of?
You
This
just
makes
changed
a lot of
sorry.
sense.
Yeah, exactly. So this is the different scope.
If you declared long before that scope, would that?
Well, Y isn't defined yet, so you'll complain.
Because you
No,
do,
no.
like let long and then
Yeah.
Oh yeah, okay. I think that would. I've never done it. I think that is a valid way to do it, but never done it that way.
I guess debug Y on 11 would be the test
Does
here.
this work? Yeah.
is it a
Yeah, so you
Does-
still.
Out of scope.
Does long exist down there though?
Oh,
yes.
sorry, yeah, the
Yeah.
long.
You've made the
No.
reference as well, so-
Yeah. We'll get rid of Y. And it says this is
Because it's a
thank you. These are really good questions. Like I'm not.
Yeah,
I wouldn't be able to explain this as well without these questions.
because it
Yes.
could be a reference to Y.
doesn't live long enough.
He doesn't because it tick A.
That's really good diagnostics.
Yeah. Yeah. Was that a question or a statement?
Oh no, just looking at that, that's not what a C compiler gives you.
It's definitely about eight and
Never see two things because
both sometimes, but there's a lot of thought that goes into this stuff. And they're like it's very good. You can learn Rust through just errands, things like this. And that is kind of how I learned Rust. Is you kind of just keep throwing yourself at something, and it keeps telling you you're wrong and then you kind of working in and that's the works. And then one day it'll click and you feel so smart. You feel like an absolute genius.
Is that pattern of using just like a code block or common one to control scope?
I mean, I don't do anything controlling scope like that. But
You may as well just use the lifetimes
you
stuff,
could.
right?
Yeah, I think the more common way of doing it is you could just say, instead of that, introducing all that scope is you just call drop. So you just say like,
It's almost like a using in C# or something. It's like if you do scope in that way, then once you because like you might have a block of code that's doing a bunch of stuff, and then you only really care about the result at the end. So then you can just
Why do we want to drop there?
just like that's the same as when you're all inside of a
curly braces.
I mean,
although
okay, I mean, once the main's finished, then that's dropped, right?
yeah, so basically it keeps going until it gets to the matching curly brace. So long and X will be dropped here. This curly brace. Y will be dropped here. This curly brace. Okay.
Just avoid the drop command and stick everything in unnecessary amounts of curly braces.
Yeah, but isn't after mains, if we remove the inner curly brace,
Yep.
Without calling drop Y we drop right at the end of main.
Correct. Yes.
So I don't need to explicitly write.
No, you do not. You never need a right drop unless you are explicitly saying, I never want to touch this again.
I think just my observation from this would be if you're adding in curly braces because you want to wrap something up into the scope, that's probably a good candidate for another function, because then at least you're saying
Absolutely.
this is the thing that this block does.
And that's why I never use it.
Yeah.
I just,
And then it becomes more terse because it's like this is the add function instead of like this is some curly braces.
excellent observation.
But it's cool for this situation. It's cool for this sort of exploratory situation. I'm not sure if I misunderstood actually. When you did have the braces in there,
Yes.
at the end of that brace section, Y and long both stop existing, is that right?
Yes, because
Because it
long
takes
is a
on the
reference
shortest.
to Y. So if long was two references to X, that would work.
Yeah.
But because it references Y, which does get
Thrown
dropped,
away.
Yeah.
it's fine.
Would
Does
you,
that make sense? Does that answer your question?
would you describe that as a foot gun?
The what?
What? Oh, what?
A foot gun. A way of shooting yourself in the foot.
Well, sorry, what's the full gun?
Which bit of that?
Like in some circumstances, like
Yeah.
when you had X and X or ref X,
Yeah.
it was okay for long to exist outside that scope. And when you were calling X and Y, the lifetime of long got squished. Right? It only lives within the brackets.
Sorry, to be very clear here, the lifetime of long is the same as the lifetime of X.
Oh, because
Not- not
in
dropping
that lifetime has to be as long as the longest life, the shortest.
Oh, the long-
So
Well, because the lifetime of the result is the same as the lifetime of the arguments that you've supplied.
Yeah.
The lifetime it's the smallest possible lifetime between X and X is the lifetime of X.
So this might be a scenario where you have two lifetimes, like an A and a B, so that you can have long. So your return
Yeah.
of C would be long.
I think the way I do it, I always use one lifetime because that way it says get the smallest lifetime.
Yeah.
It always unifies down, and that makes everything super simple.
Right, but if you put long equals longest, ref X, ref Y,
Oh, this is ref X and X, so you always
Yeah.
change X to Y.
yeah.
Yep.
So now Y's lifetime is the shortest, right?
Yes.
And long can't exist
Yes.
outside those
So
brackets.
is that what you're saying is the full gun?
Well, I was just saying it's like something that
It's a
now changes more globally because of
Yes.
like calling a function.
Yeah, you're right. I mean, honestly, I never use this let long and then do.
No,
Yeah,
it's just to torture the
it's a good,
Compiler, yeah.
you absolutely need to like explore the boundaries of the language, even if you don't use it. So that's important to understand it.
But then if it was in a function like, sorry, I forgot your name, was suggesting before that you wouldn't do the brackets, you could put into a function. That would help that situation, wouldn't it? Because
No, it'd be the same,
Because you'd need to put life,
I think.
lifetime on the function.
Once the end of that function ended, it'd be the same thing.
right, but at least you'd say, I'm creating a return value.
It'd be more
No, I haven't
explicit.
thought it through.
So I think that's what this does, this line here. And that's why if you run this, it'll tell you exactly why. So y ends at this curly brace, which is this one here.
But it's like when you were saying with the clone and everything, if you change the return type of longest to string, and then on line 14 and 16 use toString, then that would solve the problem.
Yes, I think so, because it's your yes, absolutely. Because you're turning a reference into an owned value, and an owned value can live as long as the long you want. So it lives a lot long when it's owned, lives as until this thing.
Yeah, because it's no longer borrowed.
That mean the return value coming back is now no longer tied to the input parameter?
Exactly.
Okay.
What like you transform it, you give it, the memory, like the actual bytes have nothing to do with the input and the output. They're completely different bytes.
Okay. Thank you.
So let's say I modified the longest function, not long with anyway. I want to concatenate string. Yeah, let's say x to string, or is it like just plus suffix? Or
Yeah, I think there's some string x dot.
X plus one.
What do they call them, splits or something?
There's I know there's a bunch of string manipulation stuff. The other thing you can do is there's a concat thing, but I think that's only for string literals, like with the like double quotes. So I think what you would do is let's just check what if you check that real quick.
yeah, because I'm wondering like if you do it two strings, I'm wondering like
Yeah, that works.
x.
I think you can just add two strings and that just much together. We can check that. You can just say what would it be? Debug. Cool. What have I done? So yeah, there's a bunch of
It looks like it needs to start off with like a concrete string, and then you add the reference from the other string. What?
yeah, okay. I think you might need to add an answer to it. So it gets the API sometimes get a little weird and hard to unintuitive because you have the but I think what it's saying is you can add any when you have an own value and you add a reference to it. And then that'll give you
Surely it's doing an implicit like clone.
So there's no implicit clone, so that's why it says now it gives an error here, where it says x is being moved. So that's when you would need to say x dot clone.
Yeah, cool.
There's a whole bunch of like
That makes perfect sense.
Yeah, I'm not really too familiar with string manipulation. Usually what I do is I just chuck it into a format like this. And this is kind of like add strings where you can just say like that. And this is not the prettiest thing, but it works. It's like an add string.
Very, yeah. My phonics.
So I just blindly think, because I'm like looking at x and looking at y, but without the ampersand and other thing. Is that the value or is that the memory? So
it's so when it's owned, it's the value. When it's a reference, it's the memory. Pointing to the
So within the scope of longest, the
Yeah.
x inside longest.
it's not a value.
It's not a value.
It's a pointer to.
All right.
But it returns a value because we clone by the two string.
So the two string clones.
Yeah. It's a special clone for answer because string away the last.
And I guess x dot length doesn't care if x is a stir or a ref stir.
Yeah. So I think the way it's done is that it's implemented for both, and then you can just so yeah, there's common API between them. Some of them, a lot of times, common functionality is a trait, so it's like an interface. So there's a bunch like there's a trait for if you can clone something. So that what the clone does is it says it takes a thing, and as long as it can clone that thing, it takes the reference and gives it no value because it knows at least the .clone method exists.
That would only be for stuff that goes on the heap, not like you can't like clone an integer or something because you
The integer is
declare another variable
there's
equal to that
two things in
integer.
Rust is called clone and copy. So what you're talking about is copy, where it'll just, for example, like if you have an integer and a pointer to an integer, and you dereference the pointer, you just copy it because it doesn't matter. It's too small to matter.
Well, yeah, because like an integer is all on the stack, so yeah.
And you can do that with enums as well. Enums are usually copy, so because they're just like a C in C.
So if you have like, I is equal to 1,
Mhm.
and then j is equal to I, isn't that an implicit copy? Or do you still have to call copy on I?
Yes, that's an implicit copy. So copy,
Okay.
copy is like an implicit clone, I guess. Thing. I could be wrong, let's try this.
Because yeah, so now I'm pretty sure on the stack you've now got I and j, which both have the same value.
So yeah, this input when something is copied, I can show you actually. So if you have enum by enum, we say it was a, and does everyone know an enum is? Is this making sense? No. So an enum is basically it can either be A or B. So if we say this, we say my enum A, that won't work.
But you can cast, right? From an enum to an integer or vice versa.
So no, because in Rust enums can hold data. So you can say C, which holds a string.
Ooh,
I
yeah.
won't explain how this works, but that's why you can't do it.
To feel like a hash table, I guess.
Or a discriminated union.
No, kind of. It's a way of the way you use it is have different states. So like for example, you could say like if you have a robot, it might have an enum like a state that's starting, a state that's in progress, a state that's exiting, and then maybe the in progress holds extra state.
So it's more like a factor.
That's
In R, there's
I'm not sure.
yeah.
So
In Pascal and F sharp, you have discriminated unions, which seem like pretty similar.
I think so. Yeah, it takes a lot of. So if we derive
how
the
they
point,
do it.
so this what the derive does is says give us the default implementation for this trait. So we can derive debug, which allows us to print debug text, and we can derive clone, which allows us to implement clone for enums. And as long as everything inside of it can also implement these traits, it's all good. But so this is the explicit clone. But then if we derive copy instead, we should just be able to say j equals I,
Oh, cool.
and it will implicitly so
Well, it doesn't like it though.
you need clone and copy because I think copy is just an implicit clone. So you only ever do this at very small data, but what that allows you to do is
So on I, can you do dot copy on that one
I don't
to make it
think copy-
explicit?
the dot clone, yeah.
Oh, dot clone.
Yeah.
Yeah, right.
Yeah.
But that's happening anyway.
Yeah. Because by saying copy, you're basically saying this data is small enough that pointer is the same, roughly the same length as the data itself, so you may as well just store the data.
Yeah.
So
So it doesn't go on the heap at all. It's
no,
just
I don't think that. Yeah, which is why that like a string, the capital S string can't be copied because it's heap allocated. So you have to explicitly deep clone the whole thing.
cool.
Right? That's good.
Yeah,